Hi, welcome aboard again for another ICS Defense Force. My name is Dean Parsons, certified SANS instructor for 515 and ICS 418 as well. Today's content, we're going to dive into critical cyber assets inside control system environments. So which one of those assets or several of those assets are critical for engineering processing? Which ones may be targeted in the past and possibly moving forward? And which ones should we protect first? So as always with any ICS Defense Force, we're going to cover everything from cookie factories to critical infrastructure. So we cover a whole ton of different applicable information for a number of different sectors in the ICS or OT space. So let's jump right in. There is a ton of engineering assets and devices we rely on in critical infrastructure, and they range quite a bit. We're going to focus on the digital assets or the cyber assets, but they range from things like sensors. They range to microwave radios, GPS devices. There are some serial devices in there. Even modems are still existing in ICS, and we rely on some of those as well. Alarm servers, front-end processors, and so on and so forth. So what I want to do with this ICS Defense Force episode is really focus on that handful of critical cyber assets that we need to protect first and foremost. And these are going to be as follows. These here that are highlighted. Now, what's interesting here is that this is going to represent many common industrial control assets found in many sectors across industrial control environments. So specifically the HMI, the PLCs or programmable logic controllers, engineering workstations, data historians, and we will touch on the SIS or active safety instrument system, also programmable logic controller project files as well. So the first thing I want to do is talk about the first asset, was the first away from the control system, which is the data historian. Now, the data historian is really a database first and foremost, and it stores information about the industrial control process. So records on how the process is making a product or how it's generating electricity and so on and so forth. As an example, in the electric facility space, the generation and transmission and distribution of electricity is tracked in the data historian. So like the amount of megawatts being generated, the demand for electricity in a region, and so on and so forth is tracked in the data historian. Now, another example in a pharmaceutical environment is an example be in the data historian. It's going to record the recipes and the amount of different things put together to make medicine or a vaccine, as an example. So you could say in a pharmaceutical environment, a data historian could contain a recipe of those medication and products, as an example. Now, what's interesting from a defense perspective when we talk about a data historian, it is a data point and an asset that is really connected from IT, but also shared connection with ICS as well. And we'll talk in a moment where that's typically located, but it's generally accessible by both, which means in this area, this device can potentially be a pivot point if an adversary breaks into IT, using the data historian then to pivot digitally through into the ICS environment. We'll come back to that in a minute with regards to where it is and how it aligns to the Purdue environment. Of course, moving beyond this is the operations HMI, the human machine interface. And on screen, you have here a human machine interface we use in ICS 515. Each student in class gets that PLC kit with the HMI that's on screen and a physical HMI. And in this HMI here, just in most HMIs, you see that it's an on-screen interface between the physical process and operators, and they're going to be using the HMI to monitor, control, and change the actual process. So as an example, as we see on screen here, we see generation of power being monitored. There's also a transmission area, and this is obviously an electric facility. And we see the transmission and distribution of electric power to residents and also the industrial environment as well. This machine here, the screen, could exist on a Windows OT asset, for example, where operators would use this to literally click on buttons, and those buttons will then have industrial control system protocol commands going to field devices. Now, what's interesting about this device is that it is commonly used to get remote access to this environment. So it can be accessible remotely inside an ICS environment, maybe outside the ICS as well. That makes it a critical asset to protect because an adversary can gravitate towards this and directly influence the process and have impacts on safety and reliability of operations. So that is the HMI. Now, going beyond the HMI, not necessarily looking at how to control the process or monitor the process, we do have an engineering asset. This is the engineering workstation asset. Now, specifically, this is the device that our engineering staff and folks use to install engineering software, and that software allows us to directly interface and connect with things like programmable logic controllers in the field. When engineers use this software on the engineering workstations, they can change aspects about the PLC, which ultimately makes changes on the plant floor. So as an example, if we were a cookie factory, our engineering workstation would have engineering software on it, like you see on screen here, and it has logic code inside of it. So if we wanted to change the amount of chocolate chips in our cookie factory in a batch of cookies, then we could do that by changing the logic in the engineering workstation software and uploading that new code, or a project file, if you will, to the programmable logic controller. And those controllers then would adjust and adapt to more chocolate chip cookies, which is what we all want in the ICS. So this engineering workstation is a targeted asset, and it's a critical asset to protect first. Of course, going beyond this, what the engineering workstation directly connects to is that programmable logic controller, that PLC. Now, the code we talked about with writing up and creating on the engineering workstation is loaded into the PLC. This PLC chassis, what you see on screen here, and the I/O cards in it and the modules, this PLC will run that code. And the I/O modules, as you see on screen, will interact with and directly change components in the real world. So this will interface with things like actuators in the real world to change opening a chute, for example, to allow more chocolate chips to come down into that batch of cookies as we make them. Now, the PLC can also be used as a SIS, an active safety instrumented system. So a SIS can really be a PLC rack as well, but the purpose behind a safety instrumented system PLC is really for the purpose of protecting people in a plant, but also protecting the physical assets as well. So PLC, and it can be a safety instrumented system. Now, one question I do want to raise for you folks is this: where do you store your logic files in your environment? Are those logic files on your IT environment or on the ICS environment? Either way, wherever they are, those logic files or project files are targeted. If an adversary gets access to those, they can understand exactly how your plant floor operates. Once more, if they get access to those files, they can actually target the engineering workstation, changing the logic and uploading new project files directly to your plant floor in your PLCs, directly impacting the environment. So again, PLC is a critical asset that has been targeted in the past that we should be aware of, another asset to protect first. Now, you might ask the question, well, where do we find these assets in the Purdue model? So let's walk through where we typically will see these. And of course, this depends on your architecture as well. Now, the DataHistorian typically can be in level 3 or 3.5 or a ICS DMZ zone. Now, this is, again, that asset that is closest to the IT environment, and again, it can be abused from IT into the ICS. We've seen adversaries do that time and time again. Critical asset to protect, and we'll show you a few minutes from now at least the things you want to do and how to protect these assets. Going a little bit lower in the Purdue model, we do see that HMI, we talked about the ability to control and change the environment, typically at the supervisory control layer or zone inside the Purdue model. In this case here, that is that HMI we talked about with regards to maybe getting remote access to it. It can be targeted to influence the control system without actually using malware in this case. So a targeted asset, I would say for sure, and definitely one of those devices you want to make sure you protect first and foremost. Now, the engineering workstation we talked about going lower in the Purdue model here is usually a laptop or a workstation. It can be running Windows as an example, as an OT device, and that's the device that's going to program the PLCs or something of that nature, RTUs as well, and even the safety instrumented system, which exists at a lower level of the Purdue model. The PLCs, which are going to be directly interacted with those EWs, are lower in the control element area, which is where you also can find a safety instrumented system. Now, you might be saying, great, the DataHistorian, the HMI, the engineering workstation, the PLC, they're all common for many industrial control system environments. And that's awesome. So let's focus on protecting these assets at the least first and foremost. Going beyond this, you might have the question, well, I'm in the electric sector or I generate power with wind turbines, for example, or I'm in oil and gas and offshore and refining of crude oil. So I'll walk you through some of the additional cyber assets that are critical to those areas that you want to load beyond the ones we have here as well. So an example of this is the electric utility sector. So digital protection control relays found in the electric sector are critical to monitor the health and understanding of the voltage and the rates and whatnot of electricity in certain lines. So a digital asset that also should be protected and be a critical cyber asset for protection in the electric sector. If we move to a wind area, wind generation, for example, or wind energy, in the top of all of the wind turbines, you have that nacelle at the top, that kind of a structure at the top. Inside of that, you're going to find your PLCs, your controllers, and other devices that control the yaw and pitch and allow it to generate as much electricity as possible. So don't ignore those critical assets in the top of each nacelle, and that is applicable to onshore and offshore wind turbines as well. Beyond that, if you're in oil and gas, specifically in oil and gas, if you have an ability to, or part of your operations is to unload crude oil to a refinery, as an example, a lot of times in marine areas, we do see big tankers doing that. If a tanker cannot get directly to shore to unload crude oil, we do see that there's things like a monobuoy, which is able to float offshore, so floating infrastructure in deeper waters where larger tankers with crude oil can pull up to and essentially unload that crude oil into the monobuoy and then underneath the sea to a refinery or some storage facility on shore. Now, in that monobuoy, again, is a control system for valves, opening valves, safety systems as well. So again, inside that monobuoy could be your controllers and so on and so forth. So as we come to the end to take a look at some questions we may have gotten, I want to take a quick look again at some of these devices which we've seen previously being attacked that we consider critical assets, cyber assets in ICS to be considered to be definitely in your group of devices to protect first. And that would be your DataHistorian, your human machine interface or HMI, your engineering workstation, your PLCs, which also can be a safety instrumented system as well. Generally, the protections can go fairly lengthy into each one of these, but generally want to at least have these assets, all these critical assets, in an ICS specific asset inventory. Beyond that, of course, we want to have at least the ICS network visibility each and in around each of these devices. And what that means is we want to be able to capture and monitor control system traffic to and from each of these devices. Of course, when you have that ability to capture that traffic and monitor it, you're looking at setting baseline to detect anomalous activity. And that's how you can find, for example, adversaries pivoting to the HMI from the DataHistorian user remote access, or unexpected commands from the engineering workstation into the field to the programmable logic controllers as well. All right, so to summarize, those are some of the top assets that we have for ICS that we really primarily look for to do defense. Beyond that, I'll look for any questions you guys have today, and we'll go from there. So looking at the comments question, well, a lot of folks here today. This is fantastic. But of course, we have another note and shout out for the ICS Summit as well that's coming up. Super cool. So that is in June. Looking forward to that. Wow, there's a questions. So I'll pick some at random as we go through here. Interested to see how we tackle this problem. So Sandeep, thanks for joining in. And I think if the problem is how do we protect them, or maybe the problem is how do we define them? So there's a couple ways you can determine which assets you have that are critical in your environment. There's actually a methodology we have, a 4 kind of step methodology to use. So we can probably pop that in the comments there as well. So it's a great question. Thanks for bringing that up. Yeah, we do have it there, the 4 methodologies for asset identification in ICS. Fantastic. All right. Another question here as well. What if consumers have a central backup repository, which is off-site and possibly on the business network for off-site backups? It's a great question. So thanks for joining in on this. And specifically, I want to say, awesome that you have backups. The location of the backups may be different depending on your facility and any kind of adherence to regulations as well. I would be very cautious on taking ICS backups and storing them on IT networks. Be cautious of that, making sure, of course, you have the data available to you, and any data from the ICS is kept in a sensitive area if you're deemed to have it in a sensitive area. Specifically, I'm talking about NERC and NERC-CIP, where information from the ICS must be protected through certain criteria. So in short, love that you have backups. Be cautious on where you have the backups, though. All right, let me see if there's another question here. Yeah, so Wes, thanks again for joining. What are some tips in identifying wireless devices? Yeah, great question. So if you're talking about 802.11, so devices on site Wi-Fi, there's a couple ways you can do that, which brings us probably to the next episode we're going to have, which is really going to be when you get to site, what are the things you want to do to prepare to get to site? And when you get to site, what do you actually do? Is it going to be setting up instant response? Is it going to be hacking the physical perimeter? One of those specific things when getting to site is exactly answering your question, which is how do you find these wireless devices? And one method is literally to ethically hack your ICS perimeter passively by looking for Wi-Fi hotspots that may have been around or somebody has maybe plugged in unknowingly that it could impact your industrial control environment. Great question. So keep an eye out for an upcoming episode on getting to an ICS site. All right, so another great question here before we end today's session. Edwin indicates the question of what kind of protection can we do for PLCs? An excellent question. Typically, PLCs, of course, today anyway, do not have common antivirus solutions as an example. There are some ways we can perform hardening, for example, on the PLCs. But one of the things that I find is very simple to do, and a lot of organizations are doing this, it's literally understanding at the very least what changes happen in the PLC. So let me back up here. If a PLC changes, the first question is, was it an authorized change? Did engineers sit down and go through the possibility of that change, go through a change board? The next practical thing to do to defense on a PLC is literally every so often, depending on your organization, take a hash of the project that's uploaded to the PLC. That's quickly going to tell you if the project file, the logic in the controller has changed recently. If it has changed, know that there's something potentially malicious happening, or it's an on-plan or unauthorized change. So great question on that. I think beyond that, it's really all about monitoring traffic to and from the PLCs. Yeah, and other thing is the PLCs typically have a key on them, which allows you to set the PLCs in run, remote, or program mode. If they're program mode, they're typically not running, which takes the plant offline. Be careful of that. If it's in remote mode, that means the PLCs can be accessed remotely and programmed remotely. So a protection could be only enabling that key to do remote programming in situations where you know a change is coming, that's legitimate change. So great question. All right, so that's all the time we have for today's ICS Defense Force. Super great questions, everybody, and I'm definitely looking forward to the next ICS Defense Force we have as well, so please keep an eye out for that. Otherwise, definitely want to thank you guys for coming in, and I'll talk to you guys later. Thank you.